Hello, this is Tom from Tutor Bros. In a previous video, we learned how to establish triangle congruence by SSS and SAS. In this video, we're going to tackle two other ways by which we can prove triangles congruent, and they are the ASA and the AAS postulates. ASA, or angle side angle, tells us that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent to each other. And AAS, or angle side, tells us that if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent to each other. So the main difference between these two postulates is whether or not the S, or the side, is included, meaning whether or not it's between the two pairs of congruent angles. So let's see what we can do with these postulates. Now, number one, we have a pair of triangles, and we have two pairs of congruent angles. So there's two 90-degree angles right there, one in each triangle, and then there's another pair up here. Now, in order to use either of these two postulates, we would also need a pair of congruent sides. And we're not given that outright, but you'll notice that these triangles do share a side. So this segment here, AC, is a shared side of those two triangles. And that side is between the two pairs of congruent angles. So we actually can establish triangle congruence here by the angle side angle postulate. Thus, our answer for number one would be triangle ABC is congruent to triangle ADC by the angle side angle postulate. Okay, how about number two? So we start off with one pair of congruent sides and one pair of congruent angles. Now that in and of itself is not enough to establish triangle congruence. But if you remember from the previous video on this topic, we had a similar setup with two triangles where they were formed in part by two intersecting lines. And the lines created two angles opposite each other. So I'm referring specifically to this one here and this one here. Now, those are vertical angles, and vertical angles are always equal to each other. So we actually have two pairs of congruent angles and one pair of congruent sides. Now, the sides are not included, meaning they're not between the two pairs of congruent angles, but they do correspond to each other. So side AC here and side DE correspond in each of the triangles. So we can prove triangle congruence by the angle side postulate. So our answer for number two then would be triangle ABC is congruent to triangle EBD by the angle side postulate. All right, now let's take a look at number three. This is probably going to be the most challenging of the trio. You'll notice that we're really not given a lot of information at all in this diagram. But the one thing that we do know is that side AB here and side DC are parallel. So let's see if we can do something with that. Now, what I want to do is I want to reconceptualize this a little bit. So try as best you can to look at just the parallel sides. And then notice that this diagonal that cuts into this four-sided figure is like a transversal that's cutting through two parallel lines. And we remember that all of these special relationships between angles occur when a transversal cuts through parallel lines. And the one that I want to remind you of is the alternate interior angles. So remember that alternate interior angles are angles that are on the opposite sides of a transversal but are between two parallel lines. And those are always equal to each other when a transversal cuts through those parallel lines. So it may be easier to show if I just write these little dashes here and here. So those two angles that I've indicated are alternate interior angles. And we know that they're equal to each other because that diagonal cutting through this shape is going through a pair of parallel lines. And we can say the same thing about this pair of angles, this one here and this one here. Those are also alternate interior angles and thus are equal to each other. The last thing I want to point out, and we do need this bit of information in order to prove triangle congruence, is that this pair of triangles also has a shared side, same as in number 1, and that shared side is right here. And that side is between the two pairs of congruent angles. So once again, we can use angle side angle to establish triangle congruence. So our answer here would be triangle ABC is congruent to, let's see here, it would be triangle CDA by the angle side angle postulate.